In part 1 of our lesson on the inverse circular functions, we will do an algebra review of inverse functions. Remember from your algebra class that the inverse function of f is f inverse. This notation, it's not f to the negative 1 power. It's not an exponent at all. It is f inverse. That's what that notation means. F inverse is the set of all points y comma x such that x comma y is a point on the graph of f. So if you have a point xy on the graph of f, the corresponding point on the graph of f inverse is the point y comma x. You switch the x and y values. Now, in order for f to have an inverse function, f must be what we call a one-to-one function. Now, when you're looking at the graph of f, it's very easy to tell whether it is one-to-one or not. If it is, it will pass the vertical line test, meaning it is a function, and it must also pass the horizontal line test to be a one-to-one function. Let's look at this example here. We have f of x is equal to x squared plus 2. Now we recognize that as the graph of a parabola whose vertex is at 0, 2. So here is this graph here. It passes the vertical line test, so we know it is a function, but it fails the horizontal line test, meaning a horizontal line passing through the function hits it in more than one point at a time. Since it fails the horizontal line test, that means it is not one-to-one. Now, what you learned to do in your algebra class, to make it one-to-one, we must restrict the domain. Remember, domain is the x values. So we have to restrict the domain to those x values that will let the graph pass the horizontal line test and still yield every possible y value in the range. So what we're trying to do is, when we look at this graph, we are going to limit the choices of x values to be only those x values that will allow the function to pass the horizontal line test, but still give us every possible y value in the range. Now, looking at this graph, the range of f of x is starting at 2 and going to positive infinity. So let's go ahead and fill that in this chart. Now, when we restrict the domain of f of x in order to make it one-to-one, the resulting range still has to be 2 to infinity. And the way we could accomplish that here is to restrict the domain to be x is greater than or equal to 0. So it would be starting here and going along this part of the function. And what we would do then is we would be getting rid of this part of the function. Now it would pass the horizontal line test because a horizontal line would only hit the function in one point, and yet we still have every possible y value from 2 to infinity. So we will restrict the domain of f of x to be 0 to plus infinity. In other words, x greater than 0 is the same thing in interval notation as 0 to infinity. Now let's take a look at our graph of f of x. We're going to plot it over on this other coordinate plane. We know we have the point 0, 2. We have the function. If we were to plug a 1 in for x, 1 squared plus 2 is 3. So we know we have the point 1, 3. We would have the point 2, 6. And we know our graph looks like this half of the parabola. And this is our graph of f of x. Now, let's make a graph of f inverse, remembering that f inverse, by definition, is the set of points y comma x such that xy is in f. We take the points of f of x, switch their x and y values, and we're going to get the graph of f inverse. So instead of 0, 2, we would have 2, 0. Instead of 1, 3, we would have 3, 1. And instead of 2, 6, we would have 6, 2. So this is our graph of f inverse. Something to remember is that the graph of f inverse and the graph of f are symmetric to the line y equals x. So that means if I took the graph of f and folded it over this line, it would land right down here on top of this function, f inverse. Now let's take a look at the domain and range for f inverse of x. Looking at the graph, we can see that the x values start here at 2 and go forever in the positive infinity direction. So the domain is 2 to positive infinity. And the range for f inverse, the smallest y value is here at 0, and then it goes up from there. All these y values get bigger, so the range would start here at 0 and go up. So it goes from 0 to infinity. So notice what happened to the domain and range. The domain of f became the range of f inverse. The range of f became the domain of f inverse. And that makes sense because remember how f inverse is defined. You take the x and y value from f and switch it, and it becomes f inverse. So then it makes sense that domain becomes range and range becomes domain. To find f inverse of x algebraically, we start with the function equation and we replace the f of x with letter y. So let's look at this example. We have to find f inverse of x for the function that we had in the previous graph. F of x is equal to x squared plus 2, with x being greater than or equal to 0. So f of x is y equals x squared plus 2. So we've done that first step. The second step is now that we switch x and y. So now we have x is equal to y squared plus 2. Step 3 says solve for y. So we would subtract 2 from both sides, and we have x minus 2 is equal to y squared. So by the square roots property, we would get that y is equal to plus or minus square root of x minus 2. But remember what we said happens to the domain and range. If the domain of f is 0 to infinity, right? That's what this is, 0 to infinity. That's the domain of f. That has to become the range of f inverse. So because we know the range has to be 0 to infinity, we can only accept the positive radical. So then we would have y is equal to positive square root of x minus 2. And in the very last step, we replace the y value with f inverse. So then the inverse function is f inverse of x equals, now the f inverse is replacing this y, so what it equals is the positive square root of x minus 2. Furthermore, just as a little side note here, you can think of functions and inverse functions like machines. Suppose we have a and we put it into the machine called f. Now what that's going to spit out is f of a. Now if you take f of a and input that into the machine called f inverse, then what it's going to spit out is a. So you get right back where you started from. So in other words, if you take f inverse of f of a, you end up with a. Or if you take f of f inverse of a, you also end up at a. So a function and its inverse function undo each other.